Hello everyone and welcome into yet another live stream, and today we will be, give me a second, there we go, it's the stream, full camera, and it's black, cause it is not set up correctly, whoops. Deactivate and activate, deactivate, activate, please walk, please, if you may. Now would be a great time to walk. Configure video. I don't. It's just not. I know why it's not. I know why it's not working. Okay, well, because it's not connected. That actually explains a lot. Alrighty then. Now, today we will hopefully finish up the design, the basic idea for design, because that's what I have in my calendar for today for this. So hopefully we'll be able to do it. I don't have any coffee. I haven't drunk any today, so I might be dumb. All right, there we go. And a 4. It ain't working. Why ain't it working? It's GoPro. Is it you or I have so many points of failure in my. There we go. Now it's working. I cannot really put it down like so. Maybe this way. There we go. And like fudge. Not what I meant. No, you're such a mess already. Great. I'm thrilled. Already. All right, this is still here, by the way. Now, finally, I've set it up. All right, let me switch back actually, because I'll have to set up everything we'll need in order to design. Actually, I haven't really checked what's the best program to design circuits in. Like, if I wanted to design a circuit, what should I use? What to use to design circuits? Let me just switch you up. There we go. Design software programs. Yes. Is it like a that's powerful Photoshop. Eagle. Oh, you mean like these ones? No, I was going something. Ooh, that's what I was going for. Wait. Up to 16 layers of copper, 40 million components. Proteus. Oh, that sounds lovely. Is it expensive? Or is it even, is it free? Not really. Software. Yeah, this is exactly what I'm looking for. Find the right package. Oh, I don't like that idea. What does the right package mean? Whoa, let's just do the buffer cells, right? That's simpler, easier, more convenient. So I suppose for the prototype, right, the prototype of a plan, we'll use paint, because why not? That's note over here, this the fat rats, because we need some cool music in the background. There we go. So we need to design it. We will have an input, right? Input output. Now here's the basic idea. We will get 5 volts. That's the stable. When it comes to the current I'd rather work with a variable for this. E is equal to 5 volts, and we'll have also I, because this I could range from 0.5 amperes to 4. or even maybe to 8 on some chargers. So, you know, I'd rather have it like this. So, come fly away with me. Alright, so we'll have a circuit, we'll also have a battery. Now, our battery charging place will be fit for 4 different batteries. Like so. Each of them needs the same current, and we need all of them to get the same resistance. That's a bit of an issue, honestly, not gonna lie. It's annoying to say the least to come up with that, because we will need to create current dividers that aren't voltage dividers. And it's pretty difficult. Basically, over here we cannot have any resistors, no resistors. This has to be just cable. Now, when it comes to current, if we want to divide, okay, what's the current divider equation? Again, if I may. To be afraid everything will change, you and I jumping off the edge. This dream is never done. So, current divider. Here it is. There's our equation for a current divider. So the way this would work is current divider over 3. Yeah, we need more than equation with multiple resistors. Oh, there's this. Yes. So we just get the total resistance of this. Then voltage equal to I total, this total. So yeah, so hence we get the current, and then what? Well, then I of II, which is quite comical. II is equal to I total, complete resistance divided by the I resistance. That doesn't seem the same as this, because over here should be complete resistance, which is R2 plus R1. Over here should be R1. That's off, way off. That's a different equation. Over here. Total resistance divided by... Oh, unless this is simplified already. Wait, let me check. Because then, in our case, it will be... So we have R2, right, divided by R1 plus R2 times I, capital. Then this should be equal to I, so total I, times, this is the total resistance, which basically means R2 plus R1 divided by R1. Then these two should be equal, because these are two different equations, both of them should be correct. Why is this equation? Yeah. I wanted to check. No wait, this is total resistance. Ooh, almost got me there. Total resistance, R1. Now, total resistance. First of all, we can divide both sides by I, which basically means that we get R2 divided by R1 plus R2 is equal to total resistance divided by R1. Now, total resistance because this is parallel, right? Then total resistance is equal to 1 divided by 1 divided by R1 plus 1 divided by R2. We can put this in. Yes, I suppose. There's a lot of divisions. A lot of divisions. So many divisions. We can put this in over here. Then it's 1 divided by this. One divided by this, divided by R1. So you have 1 divided by x on top, right? 1 divided by x divided by y. Then what is it? Then this 1 divided by x divided by y. So 1 divided by x times 1 divided by y. 1xy. 1 divided by xy. That's the equation. Great. Sick. So over here, so total, this should be this, right? And so because of that, R2 divided by R1 plus R2 should be equal to the total resistance, which is this. So 1 divided by R1, 1 divided by R1 plus 1 divided by R2. Something smells fishy here because this should be R2. Actually, no, wait, it seems correct. Plus R2 should be equal to 1 divided by 1 plus R1 divided by R2. These two should be equal. Now we can multiply both the bottom and the top by R2 and we get R2 divided by R1 plus R2 is equal to, multiply top and the bottom by 2, we get R2 divided by R2 plus R1. I feel smart already. These transitions are just sick. I had to add the link to my Discord. Charity checkups. Add streams. There we go. Yes, so we can use both equations, which is convenient to remember. We can use both of those equations. This one will be more convenient because it's more generalized, right? So let me just open new tab. Let's open docs, my notebook for equations. Alright, and over here, current divider equation. It is very simple. Insert equation. Let's do it. R total divided by R I times I total, and I is equal to this. Yeah, okay, that's our current divider equation, which means that over here voltage should stay constant, at least I'm hoping. I'm hoping it will. So that over here it means that we just need 4 resistors that will be all exactly the same, right? That's it. Yeah, so what we should do over here is we should put 4. So if we leave it this way, by the way, it will be fine already. If we leave it this way, then it will be alright and everything will work out just fine. We can just use a resistor here before this entire thing. Yeah, that's it. Let me just, by the way, just get some lights over here. Let me also fix up one thing. There we go. Alright, back to the stream. And so here's the idea. We can put resistor over here, except we obviously won't use a resistor. We will use... I had no idea Ctrl Z works in OBS. I'm very sorry for that. Misclicked. we won't use normal resistor, we will use potentiometer, digital one, obviously. Now, this digital, yeah, it will be a bit problematic. We won't really have a place to get rid of the extra current. We'll just have to chill there. But the basic idea still should stay. If we get too much current, right, if the I will be too large, we will just decrease it. All this could be basically handled by Raspberry Pi, which, speaking of, Raspberry Pi current detection. Well, not really detection, only measuring. Raspberry Pi and Pico, that's important. Pico current measurement. That's exactly what I'm asking for. There we go. How to measure? Please tell me there is a way to it. How to measure peak current? No, this is not quite what I'm looking for. Maximum input voltage of 26 volts and maximum current of 3.6 amperes. By the way, that is a lot. May I just mention? Just 93 watts. Okay, pardon me. We can pack 93 watts into this thing, and it will be fine. Into this. That's insane. That's insane. Alright. But yeah, maximum current 3.8. That's already good. But we will have to check still. That's hopeful. That's very much hopeful. There's design device power monitoring. A single monitor was enough. Okay. It's just a simple question. Can Raspberry control it? Connect a current monitoring controller. That sounds like a hardware part. That's honestly sounds like an external hardware. Oh, I would really like money, but no, sorry. Wrong Raspberry. Did I specify Pico? I did. Current monitoring controller, not quite. By current measurement pin, maybe that'll give them an idea. Measure pico current. Okay, we might need to read this. Back one day also. Very good sound. Alright. Amp meter. Alright, that's not. Because I'm pretty certain you can measure voltage, right? Measure voltage on pin in Raspberry Pi Pico. Yeah, we don't have to re-specify W. There we go. GPU pin level for voltages. ADC input multiplying. Alright, now the same thing, except instead of voltage, we would like to measure current. To be fair, we could, I'm pretty certain Ohm's law works, but that would require thinking, and I'm against that. So, the lack of articles about this issue leads me to believe that it is not really a thing. Current monitoring control. That sounds like a thing, actually. So you can't. That's what I'm getting, right? GPIO maybe? Current measurement. Oh yes, that's measurement. First time. Put the 10 amperes. Wait, what? The current measurement of Raspberry Pi GPU. Since the first time I was moving measure DC current on the Pi, anything. Oh no, wait, that's stretched up with the. That's not quite what I'm looking for. I'm about to bing this. Honestly, I'm about to bing this. Can you check the input current Raspberry Pi Pico maybe code? Maybe this will give it the right idea. Yeah, it must include current. Measure Pico current, that's the same thing, right? Yeah, it's about something else. Current sensing element. See some current below amp meter. Yeah, so it's a thing. 0 amperes of Pico draw less than 10 when running blink. So this lot was just measuring how much Pico. Not what I'm looking for. We could use Ohm's law, I suppose, because we can measure voltage, and we could just get a voltage divider for ourselves over here, right? Because obviously we're not putting all of this into the Raspberry. First of all, that would be a waste. Second of all, we might kill it with the right setup. So instead what we'll do is from the input we will set up a voltage divider, and we will send voltage and current divider preferably, actually. Oh no, actually, you know what, current divider might be problematic to get there. Problematic, say the least. How about maybe it would work. Wait, if we connect one as a source of power to Raspberry, second as a ground, then it should work. Maybe I no idea what you can now. So, what you thinking? Well, I suppose that could work. They would measure only voltage, and we should get the current from that. Hopefully, somehow. It wouldn't be a walk in the park exactly. So the system by itself would look like this. We'll have the input. From the input we'll have the, well, let's miss that for a second. So we'll have the input, from which we'll get a voltage divider, right? This will need another resistor before heading into the Raspberry Pi. Actually, okay, R might be P, like Pico, or Pi, or Raspberry. Anyway, voltage divider, there's only fraction of that over there. Now, this power will actually go to power on batteries, which will look like this. And because of how nicely just so happens current works, this will divide current evenly, right? Those batteries, very convenient indeed, handy dandy, which means all we'll need is a potentiometer over here. Like so. I am connecting the right way to the Raspberry Pi because, you see, this will be a digital one, so it will be connected multiple ways to it. Now, Then we'll get out of these batteries this, and this will go back over here. The one dish, this will be ground too, and will be connected and ground. Everyone lives happily on ever after, but that's the first part. That's the easy part, right? Over here, right now, we have a circuit which allows us to, well, obviously with no hard values yet, but we have a circuit which allows us to charge batteries and to control the flow of charge, control everything when it comes to these batteries. But we still have an issue, because you see, we are blind. We are very strong, but we are blind. We cannot really see what we are doing with these batteries. And because of that, what we would need to do is we would need to get a read of these batteries. How are they doing? Which, well, is actually the only thing left to do. So I should focus on it. Reading battery charge whilst charging. Because I assume there will be some problems with that. Battery voltage whilst charging, yes. That's, yeah. All the time need to control, yep. How to control? With voltage sensor circuit. So I feel like that's too complex in comparison to what we need, right? If the battery is over here, this you couldn't even see it. Sorry, pardon me. Battery is, no, you could see it. It's down. I'm an idiot. If the battery is this low, like at the end of the circuit, then boy, am I glad. Let me just make this a bit smaller. There we go. Also, this should be probably in the corner like so, and probably also smaller, and probably like this. And probably even smaller. Yeah, now it's less of a mess. All right. Voltage circuits often. There's the voltage divider. This seems an overkill, doesn't it? We have a voltage sensor and a current sensor. These are grounds, by the way. So I know we need all that. I really do not know if we need all that. Only to the main parts. We could charge it. We need some protection circuit to resist short circuits. Discharge, harsh electrical environment, unstable source, etc. You may even want to consider redundancy in sensors for safety. All depends on the application. I will. .48V 10 amp output. That's not what we are doing. We are making a smaller one. But okay, this output, by the way, this is output, not input. That's very important. Yeah, because input, okay, I kind of get, okay, maybe. I mean, it's doable to draw 48 volts, 10 amperes. Okay, it's doable to draw that, but output. That's car batteries. Well, actually, maybe, I don't know. Actually, car batteries. That would be kind of killer car battery. Detect electrical current in circuit generates signal as proportional to that current. £1.593. I don't get this price. All right. So this is this. Is this the same sensor? No, it's not. Sort by price, obviously price. Well, actually wrong way, I think, right? Yeah, okay. Current sensor, solid. I don't need anything too powerful. Oh, by the way, this is in bulk. I like that. Like the sign. Unavailable tobacco. We have this product in stock. The minimal option is kind of large. Data sheets, I like that. I would like that. Temperature range, solid. Output, an external resistor, B sets, I hold threshold. Fine, let's check this data sheet. Only 9 pages, surprisingly short, like extremely short. Really, they have 40 or maybe 400 depending on stuff. But to be fair, this hopefully is simple. Alright. Supply input. Power supply 10 milliamps. Those well, I suppose it wouldn't really matter if we just set up a current divider again and we give it, you know, like 1,000th of an amperage, then I suppose. Voltage. That seems actually a bit too simple. This is still kind of one thing I don't get. You know, when you're researching the laws, right? Then they said that if you have a complex circuit, you can basically transform the entire circuit into a source of current and a resistor to simplify it. But if we can do it, then it seems just too convenient. Because then to measure current, we could measure it based on voltage. If we turn the entire reservoir circuit into a current source, right, with this, then based on Ohm's law, this would have some sort of current, this would have some resistance, we can calculate both, and then voltage will just tell us. Voltage would tell us exactly what the current is. Maybe that is the way to do it. Because then we have this. Then we can just probably do this. Obviously we'll have to connect that to each battery, right? Or maybe it might not even, well no, we do need a separate reading from each battery. Which means how many pins for us? Well, it means... It means 4. We don't need to go from, we need to go to. Like so. And now only we have to figure out a way to measure it. Seems to be, no, I've learned the rules, but the rules are too simple for this. It cannot work this way. The rules are too simple. I refuse to believe. Okay. I feel like I should connect this and check for myself. So I should just charge the battery. Yes, let's do it. Let's charge the battery and let's try to figure out the thing. So, the message. Is it? Who's the message from? Oh, I got paid! That's so nice. Such a nice message to receive. I've got paid for the job I did recently, right? You know what they say? Get paid, get made, and have your daily chores made. Wait, I can't see the chart. Oh wait, Tefta, you were telling me stuff on chat. I cannot see chat for some reason. Why can I not see chat? I just right now when I took a phone I realized, huh? Now I see. What, just YouTube? I can't see chat. I'm very sorry for that. I just multimedia from eBay, just unlock some sort of features. Come over function into this little thing. Open source multimeter, so it might have documents of what you're doing. Yes, it certainly might. As voltage ranges, yeah, again, search electronic again. So wait, give me a second. Let me first I should probably check what I was going to check, because I feel I should build up an understanding for it at this point, but I haven't yet. So just get rid of this. Thank you. Over here. Okay, sick. So this we connect. Anthony. Alright. Let me just actually disconnect that. It's connecting in a very awkward way. I need this to be upright. Exactly. Perfection. Now we have this over here. Let's just, do a normal check if everything is working correctly. So this is ground from memory, and this should be pin 0. Connect ground over here. Pin ground a pin. Let's do it over here, might as well. Diodes. This one's really dim. Where's the bright yellow one? Over here. I have no idea which one is plus, which one is the minus. This one's the plus, alright. Understood. There we go. Tony. From machine import pin. Pin 0. Pin out. Value 1. Okay, maybe that's the wrong pin. It's fine, no need to panic yet. Images, if I may, just quick the pins. There we go. Pin out. See this. Alright, this is the numbers, if I may. Oh, this is GPO 6. Is it the same with this one? 0. It is 0. Did I do 0? I did 0. If I did 0, then what went wrong? It's a good question. Multimeter to the rescue. Okay. Multimeter to the rescue indeed. Looking for anything. A 0 is very much, zero very much could be described as nothing, but that might be due to the fact that I did not know. So 0. Ay. That's awkward, because I just turned on. Let me just over here, then you can see both. So, that's bad news. The third one is ground, right? I need to check. Let's just third one is ground. Yes, I'm correct. Damn it. Never been pissed about being correct. Let me just this over here. This over here. -3, yes. Now what happens if I change the value to 0? It drops. Okay. So this works. It just I'm not connecting the pins properly. Great. Now let's do it differently. Now let's print. If I could spell it correctly, it would be sick. 0 pin dot in mode in I dot value. Not quite ADC. All right. From machine import ADC pin 0 pin in. ADC is not defined. What did I misspell? ADC, obviously, it's all caps, makes sense. Pin doesn't have ADC, okay, it's fine. Which one does then? This one still, okay. 26 has, cool. Understood, 26. C channel 0, alright. Great. Manual, okay, so pin 26, which is over here, because it's ADC. Alright, so we have 3 pins. Oh, 3! That's... Ay, caramba! 3. Well, I suppose we could use transistors. Yes, okay, never mind. We can use transistors. That's not the crisis yet. We can use transistors that would determine from which battery thing goes to the pin. It's fine. It's fine so far. So we can basically use the digital pins to control transistors, and these transistors could determine from which battery is it going to the Raspberry. It's fine. All right. Now the only issue for me is the battery itself. So the way we are going to do it is we are going to collect, don't mind the fact they're just lying around on my desk, resistors, because these I hope are 10 ohms. Let's check. It's hard to get 10 ohms resistor. We wouldn't have lost them. 10, yes, this is correct. Now we need the other one. Which is this one? No, it's not. No, the other one should also be curved. My disk is a mess from recent streams. This one. That looks like a 10 ohms resistor to me. We can get them both together, we can read it as 5, but no, we'll do one time. 10! Can you see it? You cannot see it. You cannot see it, and says 10. Alright, now we just have to build a simple battery charger. Not a problem, because, well, it's really not a problem. We just set up a simple voltage divider. Let me just switch to full camera because I'll be doing it over here for a while. And also let me just go and get the lights on, the big lights on, like this. Oh yeah, should be much better. So, a simple battery charger, not an issue, been there, done that. It's just, we set up a simple voltage divider because you see we get twice the amount of voltage we need, so we need to half it. And this just does the trick. Now this will be our battery for today. This little bugger has how many volts? And this lot has 152, which is very much a little. It's a little, not a lot. It should have 1.2, but it's very much decharged at the same time, so. So what we are going to do is we are going to start our little tiny power supply and get them some juice over here. Get them some juice on the other side. I should use blue for this if I'm being correct. Now we can just measure if, you know, a sanity check, how our little thing is doing. We get in between these two nothing. That's not good. We get nothing. That's that's not what we are looking for. Bob, I'll need your help. This is Bob. Say hi to Bob, everyone. It's the first time Bob is helping us on stream today. So we'll get a minus over here, like so. I just did a minor disconnect on my thing, and now maybe the other way. Nothing. Nothing? That's bad. We weren't going for nothing, we're going for something. Actually, so that's suboptimal, very much. How about if I plug this over here? Please just light up and walk. Nope, nothing. Oh, I can see why, because this one was plugged in incorrectly. But now I have no idea why it's not going actually. 3 volts on this side is wrong color. Who would have thought? No, not it. Nope. No, that's great. That's fine. I was expecting problems. Mate, start. It's time to start. Just please walk for a second. Please. Magic, Alakazam. I don't know anymore. Magic words, alright. This is an issue. This is truly an issue because something is wrong. Like every single my live stream starts with troubleshooting problem. Did I ban this? I might just have banned this. Which sadly, well, wouldn't be that surprising honestly, if I'm being honest, truly. Bob Holland, this and this. Thank you. Now let's check. We are getting reading. So there is juice in them. 2.38. Which is incorrect. There should be 5 volts, but who am I to judge? Honestly, who am I to judge? Alright. If I connect them to this, does it light up? It doesn't. So is it just diode that's dead? It might be. I'm not saying it isn't. You good, mate? Nope, you're also dead. Okay, how about the other way? Actually, no, it is the same way. I think. Suddenly not lighting up the other way. Nope, okay. I'm going for a different diode. Listen, team, we need to be on point here. Okay, my dear diodes. My dear diodes, I am in need of your assistance and it would be very nice if you could let's put this back in. There we go. So the diodes were just great. Festive. Now, this second resistance, double voltage divider, we've done that already because we get 2.4 volts and we want 1.2 because that's the voltage of the battery. So now over here, oh, wrong cable, this one, good enough. Bob, hold on to this for me, May. Thank you so much, and we'll just get the second blue one as a ground. Now, we should get 1.2 volts. That's the hope, at least. We get 0.95, close enough. Yes, that's good. So we set up voltage divider. It's a simple circuit, nothing to be excited about yet. Just go with it. Now we have to charge a battery, which is more difficult actually. Logistically, not really. It's difficult logistically, not really actually intelligently. So I can get tape, I suppose. I feel like every single one of my ideas just starts with tape. It's exciting. Get some tape. Because we will just try, right now, we'll try to design a circuit which can measure voltage and current of a battery on Raspberry Pi. Voltage we will be able to measure easily. Current, well, that's the difficult part. I feel like if we could regulate resistance, then maybe. Right. Now, let's tape to the battery this. Would be a plus. one half taped. Good. It's really tempting to solder this, but these batteries are good. I don't want to lose them. They can still be recharged. That's the entire idea. Now we'll try to figure out if we can... two things. First of all, we'll try to figure out if we can check the voltage of the battery whilst it is charging. And then we'll also try to figure out if we can check the current. So, this just came off great. Sick. Love that. Stick to it. Stay there. By the power of tape. Stay. Please. If you may, okay. Don't unglue yourself. Unglue. That's a verb, right? To be unglued. Oh, fudge this. You lads are unbelievable. Absolutely unbelievable. Alright, I'm getting stronger tape. That's it. No more fun. We're using the stronger tape. No more having fun. There's no having fun on Make It streams. It's new rules. No one's allowed to have fun here. We're here to experiments. No fun allowed, only science. Alright, let's... Alright. Stay over here. I could solder it, but as I said, I don't want to. I don't want to solder this. I do have a battery case, which I could repurpose into a single battery. Okay, yeah, you know what, that actually might not be the bad of an idea. Because I do have a solder. So that's kind of the only thing we need for this. So over here we have this, which is, oh my goodness, I really would need some. I would really need some budget for these streams. My goodness, because you have no idea of how little space I'm walking here. It's genuinely hard. All right, this over here. Let's get this out. Out, if you may, please. All right. Here's the basic idea. This right here can be, I can break this because its services are no longer required. We need a single battery thing, not a multi-battery thing. And even if we'll need a multi-battery thing, we'll figure it out. There's a resistor here, nothing that interesting, so we can get rid of it. Just leave it, I suppose, sticking out. Yeah, no one will mind. Now, for this, I would rather cut this cable if I just... Thank you. And just solder a very solid copper wire, which I have. You may remember it from last stream, because this still holds. It still holds. It's a very solid copper wire. It's laying on the floor right now, so you can use that. Will be convenient. Now, the problem is it's very stiff, which basically means that we might have some real issues with positioning stuff on this table. I already don't have the space. Let's just cut the tip off, like so. There we go. Here's just the tip. Now let's get rid of rubber on the tip. we go. One done, one more to go. Over here. There we go. Now the other side. We need 2 sides. There we go, both sides done. Now we can solder them to the required things. The required things being this case right here. Alright, just give my solder. Oh, chill, wait. This scares me every single time. Alright. Just hold on, actually, you know what? I might need to solder it to these two, which basically means I might need more space. Just bring the wall to them. Alright. Off and there we go. We'll solder these like so. That will be, we'll get batteries on both sides. Yeah, it's a dumb solder, not gonna lie. I'll probably destroy this entire nice casing here, but you know. It's already melted, but it's so quick. This solder is so goddamn good. I mean, it's insane. Alright, I might need the carton thing. Oh, it's a mess. Normally I would love to just move things to a different, my work desk, because I do have a work desk. But unfortunately, there are too many things here that I need to move them all to my work desk. All the time, alright. Yeah, the tips are small, but size doesn't matter. At least that's what I've been told. Now let's just get this. Get the wires nice and hot. Oh, it's smoking. That's a good sign, certainly. First one. Second one. Now it's so quick now. Okay. Now what we need to do is get this over here and solder it. First to this. Hopefully I should move away so I can see it. Right, just this is needed a bit. stick. My friend, we are going to have... Okay, I'm soldering it to the spring on the other side, because that seems like a simple task to do. Are we going to have a problem, sir? Okay, this thing is hot. Really hot. Shouldn't have a problem to solder this then. What did I do? One cable went smoothly. Why is the second one taking so long? Oh, it snapped. It did go smoothly, but then it didn't. It was going smoothly. Alright, let's bend them. Nice. Not gonna lie, this feels like a stupendium moment. This moment right here. I feel like I need something to sing to, so I won't go insane. So yeah, let's. The most fashionable faction, yes. 3, 2, 1, begin. What's that? Do you know who you're looking here? Yes, please, just go for it. I swear. Okay, we need to get code of. Yeah, just stay here. Right. For some reason the blue one just doesn't want to stick. Oh yeah, I might have been over it now. That's good. Better to over than under. That's what I always say. And then fail. So something. Okay.
Gentle when I sneak into your base and steal the faces of your helpless friends. Stealing your briefcase really was a briefcase. You think you're smart, but I have the intelligence. Be a man, why'd you have to die screaming? I shoot you, take the loot, to take my suit for dry cleaning. I'm not cheating, you ignorant swine. I creep in and sneak things right into your spine. I fight with my butterfly, stings like a bee. So tonight, tell your mother hi, give her a kiss from me. I'm debonair with deadly flair. I'm anyone and anywhere. The face you must awake to is the last you'll ever see. I am heavy, weapons sky. I make beauty, babies cry. Want to live?
Touch. Get out of this! My goodness, it's stuck in the spring. Alright, fine. I'm so great at the other button. Okay. Okay, well, that'll be proven. We got the game for you. The engineers in the field, fanboy child, make it on yield. I've got a cranium laced with uranium, dispense your fans with the weapons I wield. I'm hot stuff, 100 degrees, so you pour my blood, good, but no steep. I'm overqualified, living notified. Now the machines, just a friendly entry, preventing sentry. fucked up. Okay, this should work. Get in, get in there, get in. Get to the board. I know you can. Friends done this before you. Gosh darn it! Oh, am I supposed to shave you off? I might. If you want. Just a bit of the top, huh? I might need a sharper knife. I do have one, but it's going to break on this. Oh my god, I can't have this. Great, now it's sharp. Should be better. Should be easier. That's no fun. Who wants to battle when there's cattle? Push the camera. Long part! Get in! First one in. Second one in. Great. There we go. Done. Faction in TF2. Alright. No, where do you? No, where's many hats? It's ridiculous. That's. What's this song doing here? Spotify! Stop adding them here. Shelter from the storm. Alright. I need another battery, I just realized, because this is made for 2 batteries. Faction TF2. Most fashionable faction TF2. Alright, so we'll just have to input the batteries, hope it won't break. Don't break, please, if you may. Just don't break. And everything will be fine if you just... Alright, did this work? I have no idea. How would I know? Let's see. We should get some sort of light on this, right? On the other end. We should. Not a lot, but at least a bit. Where's the green diode? I'm really missing so much space here, my goodness. I need space. Look at this. There's the green diode. Now let's plug it in. This is minus, brown is minus. Shouldn't be a lot though. It's not a good way to check. Best way to check would be the multimeter, to be fair. That's good. That's good. There should be the voltage of both batteries added together. Should go across. What's the amperage? That does look like a 0 amperes to me, my friend. That's not a lot of amperes. Some might even call it few amperes. So there are absolutely no... Okay. And the voltage all of a sudden is just dropped completely. If I put it on the cable though, it gets nothing, which is bad news. Should get the same amount of so just the solder didn't do anything, and those will not have any charge in them, which is suboptimal for me. Oh no, never mind. It does go across. That's good. Yeah, it worked. Great. Now, if we input the charge into them, we should be able to charge them. That's it. Yes, so now all we want to try is to measure the voltage Alright, let's do it. Let's check. Like these suckers in again. Blue is plus. Yes, over here. Brown is minus. Now, well, we have to plug this in here, and we have to check if you could be help here for me, Bob, and hold on to these two. And this should be minus, this should be plus. As deliveries in time. In the center we try, yes! We get that voltage, great. So now what we have to do is charge them and check the same voltage whilst charging. So basically, the basic idea is actually very simple, honestly. If we do this, these should be charging already. They are charging. But how is our... Oh, 6, and it turns off every now and then. Or is it just me? No, so the voltage just should keep rising up, right? Slowly but surely. Really slowly. Oh, yes, it is! And we can just measure it. Aha! That's so convenient! Great, okay, that's sick. Yes, so, oh my goodness, that's so helpful. The only issue right now is the matter of... So all we need is check the input of the... All we have to do is just check the input current, that's it. That's great, that's... Tefta, may I ask you a question, by the way, if you're still here? Because you're the, you know, the what did you use to design your PCBs and circuits? Because I'll probably do the actual designing off stream, some different music. Thank you very much. Let me just... yeah. Is it free? Windows. Oh, no way. No, it's... Is it... Wait, is it open source? Is it free open source? Wait. Libraries. Mute. No worries, no worries. I think I'll be ending the stream now. And then well, off stream, I'll just design the thing. Let's see, by the way, how quickly this is charged. One, okay, it's charging, alright. You can turn it off now. Great, so it's actually a matter of just designing it. Shouldn't be that tough, hopefully. Alright. I guess that'll be it for this stream. Because I don't really know what else to do and I have a lot of stuff to do off stream. I have 2 videos for today only. 2 videos to make. 3 videos to start. Gonna move on the secret thing. Do 3 podcasts because I haven't done podcasts in a while and I want them to be also a thing that I do. So I guess for now that'll be it. Thank you everyone so much for watching and have a great day. Bye.